Hey guys, welcome to today's live session video. How do we solve this equation? X minus 5 to the power of 4 equal to 5 to the power of 4. First, let us rewrite this left hand side. We can rewrite it as x minus 5 all squared times 2 equal to. We can also rewrite this right hand side as 5 squared times 2. This implies that. Now, let's move this guy to the left hand side. So we have x minus 5 all squared times 2 minus 5 squared times 2 equal to 0. Let's continue. Let's recall a very nice property. It says whenever we have a square minus b square, this is equal to a plus b times a minus b. Take note of this identity. Now, let's apply this identity to this guy. You will see that by comparing this left hand side with this, our a is x minus 5 all squared and our b is 5 squared. That means from this line we are going to have x minus 5 all squared plus b, that is 5 squared, times open bracket a x minus 5 all squared x minus 5 all squared minus b, that is 5 squared, everything equal to 0. Let's proceed further. If you expand x minus 5 all square very well, you are going to have s square minus 10x plus 25 plus, what is 5 square? 5 times 5, that is 25. Close the bracket into, what is x minus 5 all square? You will have the same thing as we have here. We have x square minus 10x plus 25 minus 5 square, that is 25. Everything equal to 0. Let's proceed further. So we have s square minus 10x, 25 plus 25, that is 50, times s square minus 10x, 25 minus 25, that is 0. So close the brackets, equal to 0. This implies that s square minus 10x plus 50 is equal to 0, or s square minus 10x is equal to 0. Let us focus on this equation first. Let's separate it. You will see that it is possible we can factor out x. So if we factor out x, we have x into x minus 10 equal to 0. This implies that x is equal to 0, or x minus 10 is equal to 0. Clearly, x is equal to 0. This is the first solution. Let's call it x1, or moving this minus 10 to the right hand side, x is equal to 10. Let's call this x2. This is the second solution. Now, let us focus our attention on this other equation, x squared minus 10x plus 50. We won't use the usual quadratic formula to solve it. Let's solve it using completing the square method. By completing the square method, by completing the square, the first thing we're going to do is to transfer these constants to the right hand side. So we have s squared minus 10x equal to minus 50. Now, let us add half of the coefficient of x and at the same time square it to both sides. The coefficient of x here is minus 10. Half of it will be minus 10 divided by 2 and we square it. So add this to both sides. So that will be s squared minus 10x plus minus 10 over 2 all squared equal to minus 50 plus this guy minus 10 over 2 all squared. Let's continue. This is 0. So now it is possible we can combine this left hand side. So that will be x minus 10 over 2 all squared equal to, that is, when you expand this whole guy, x minus 10 all over 2 all squared, if you expand it very well, you will have all of this left hand side back. So this equal to minus 50 plus minus 10 over 2 all squared. Let's proceed further. This implies that x minus 10 divided by 2, that is 5, all squared, equal to minus 50 plus minus 10 divided by 2, minus 5, all squared. So x minus 5 all squared equal to minus 50 plus minus 5 all squared, that is 25. This means that x minus 5 all squared equal to minus 50 plus 25, that is minus 25. Now, let us take square root of both sides. So that will be square root of x minus 5 all squared equal to plus or minus square root of minus 25. Clearly, this bigger square root cancel out this power. We are left with x minus 5 equal to plus or minus. I can rewrite square root of minus 25 as square root of 25 times square root of negative 1. This implies that x minus 5 is equal to plus or minus, what is square root of 25? That is 5. And also, from the complex number, we know that square root of negative 1 is equals to I. So let's replace this guy with I. This implies that x, moving minus 5 to the right hand side, we have 5 plus or minus 5i. So as a result of this, x is equal to 5 plus 5i. So let us call this x3, or x equal to, consider the negative sign, we have 5 minus 5i. So this is x4. So therefore, all the solutions that we have for this algebraic equation, the first one is x1 is equal to, let me show you, s1 is 0 while s2 is 10. x1 is 0, s2 is equals to 10, x3 is equals to 5 plus 5i, 5 plus 5i, and the last but not the least, x4 is equals to 5 minus 5i. 5 minus 5i. So this is the solutions that is required for this equation. We have 4 distinct solutions. That's it for this video. Thank you so much guys for joining this live session video. Please share your tips Please tell me if this video was helpful, and don't forget to like and subscribe to my channel. I would love to see you in my other videos as well. Have a good one.